Hi guys, I'd like to welcome each and every one of us to my channel of Honesty Sciences and Mathematics TV channel. Today we're going to look at a very interesting topic under electricity and magnetism. And this basically is going to be on the concept of what we refer to as electric fields. Now this specific topic is going to deal with an area of influence between the charges. And this was a discussion on what they are referred to as the Coulomb's law, which gave a relationship between the force that is acting on two small charged particles, of course, which we had referred to as spheres, which gave us the relationship of the product between the product of the two charges and then the distance between them being given as such. So we decided that this is a vector quantity, and therefore we had represented this one using this specific representation as a formula for trying to give that aspect of Coulomb's law. Of course, we had said that we can be able to find this formula very essential, especially in trying to find what we refer to as the forces between the charged particles, or the distance between the charged particles, and of course it plays a fundamental role in the development of what we had referred to as electromagnetic theory. In this particular aspect for the electric field, we are going to see that we can be able to characterize this area of influence between the charged particles and try to give it a specific quantity. And this specific, of course, description is going to be what we refer to as an electric field. Now, in terms of illustration, I'm going to specifically try to categorize this one under what I refer to as a scalar vector, and what we refer to as or rather what we refer to as a scalar field and a vector field, of course, which is going to give us a difference between this specific two. But of course, this particular discussion for us is going to fall under this second category. Now that we had mentioned that, of course, we can be able to characterize what we refer to as a scalar field by trying to give its aspect of those what we refer to as, of course, intensive variables. We had mentioned about the concept of intensive and extensive variables in our discussion on chemical thermodynamics. I'm going to give a link in the description box, of course, which is going to assist us, of course, try to understand how we can differentiate between these vector and scalar quantities and fields that I've mentioned. But of course, this is going to be of literal essence for us in this specific discussion. But in this specific case, I was trying to create the difference between a scalar and a vector field. Of course, if I can be able to give it in terms of an illustration, if I have this specific aspect of perhaps a quantity that is moving in that specific direction, and this one can be illustrated using a fluid dynamics, where a particular liquid is going to move in this specific direction, and therefore we can give a representation of that specific with a particular velocity, perhaps moving in that specific direction. And this is going to give us an illustrative way in which we can be able to represent what we call a vector quantity. Now, one of the fields that we had mentioned was what we refer to as the gravitational field, which of course is going to be experienced due to gravitational force that we have given as G M1, M2, where M1 and M2 is going to be the product between, the product of those two particles which are being discussed in this particular aspect, experiencing this gravitational force. So this one, we said, of course, we can be able to represent this specific gravitational force using the product of mass and the gravitational constant, which we can be able to give us that. Of course, we know this one is a familiar figure in most of our discussion, which we're going to give it in terms of a numerical value. But of course, we can just leave it out there. Of essence for us is to try and figure out how we can be able to represent this specific field in terms of what we have called a gravitational field, and therefore we can give this specific representation using that particular aspect for describing what we refer to as a gravitational field, which can be given as F over M. Now, as we had mentioned, there's a relationship that exists between these two specific representation for the force of the gravitational force and the Coulomb's law. And therefore, we can be able to give a description for electric field using that specific similar aspect. And therefore, I'm going to give it a description. And therefore, we can be able to give an electric field as a ratio between force and the unit charge, which is going to be force per unit charge. Now, since we had given the initials for representation of this aspect of force for F and then charge for Q, therefore the relationship that is going to exist between these specific two are going to be defined by an electrical field. And therefore we can give a general formula for that one as force over unit charge. And we had said that these particular two aspects are going to be, of course, vector quantities. And therefore, in formula form, we can be able to represent an electric field using this specific formula. And in trying to look at the deeper illustration for this, we're going to see that an electric field is going to play a role of an intermediary between charged particles. And as we had said, of course, I'm going to give an illustration for our general spheres that we had mentioned earlier. Let me give this one as charge 1, and this is charge 2. If we try to characterize this one and give it as a positive charge and charge 2 as a negative charge, we're going to see that the aspect of an electric field is going to be experienced between these two specific charges, whereby there's going to be a force of attraction that is going to be experienced. If they are uniform, of course, these forces are going to cancel out. But if one of the forces is greater than another, then therefore we're going to see a resultant force being described. And therefore we can be able to describe a field as an aspect that plays the role of an intermediary, whereby we're going to see that to describe an electric field, if I try to just give a summary of this one as positive and negative, we're going to see that the forces of this electric field are going to emanate from the positive charge, and they're going to terminate, of course, in the negative charge. We try to just give it as separate charges, and therefore we're going to see that this is going to terminate the negative charges are given as such using those two specific illustrations. So if we try to consider the aspect of the charge 1, or just a charge for the general representation of an electric field, therefore we can be able to describe the electric field as the ratio between the force and the charge for the limit. Just to give a limit, we have talked about this one in of course, calculus. The limit as the charge Q0, or the initial charge. We can be able to give the two spheres for charge as Q0 and Q. Therefore, if the Q0 tends to 0, then therefore we're going to have this one represented as F over Q0. And therefore, this is going to give us a representation for the general formula for an electric, of course, a field line that is an electric field that is going to be given using that specific formula. Now, in our first case for it, the representation of other laws like the Coulomb's law that we had said, we are given the aspect of a proportionality constant, and therefore this is going to be given as Ke to represent that specific constant, the ratio of charge. But of course, we're going to do a derivation of this one in a separate video and try to see the relationship that exists. And this is going to be represented using that unity factor for R, which is going to represent, of course, the direction of that specific electric field. So generally, this is how we're going to represent an electric field in various discussions that we're going to encounter insofar as discussion on this is concerned. So next, we're going to look at different aspects and properties of electric field, which we're going to mention, of course, exclusively in other related videos, and try to see some of the properties of electric fields and how we can be able to describe them. But lastly, before we do that, I'm going to just give a summary of what we had discussed by using this, of course, common example that we have already been given. So I've said that if we consider two charged particles for A and B, and these are uniformly charged for the positive and negative charges, therefore we're going to experience what we refer to as, we do away with this, an area of influence that we have referred to as an electric field. And this electric field is going to be experienced in the spaces between electric charges, which are assumed to consist of what we refer to as arrows. So in any case, if we try to represent this one, then therefore we're going to represent this specific interaction between these two charges as this. And these other fields are going, of course, to be represented using this one. And we're going to see this one further being illustrated in the aspect of electricity and magnetism. Some of our discussions, which of course are going to be related topics on this specific case. So we can be able to represent this one using these specific arrows for the interaction between those two specific charges. But we're going to see other aspects and try to see that in any case, if you are considering the charged particles or maybe some aspects like plates, we're going to see the variation of these specific lines. They are not going to be uniform, and that one is going to, of course, be until discussion. So in this case, we're going to see that these particular lines can be represented by little arrows, which are going to be vectors being represented as such. So these vectors are going to depict the aspect of magnitude and direction of those specific electrical fields. And of course, they're going to give us different aspects of magnitude and of course direction of those electrical fields. There are different points of this specific area of influence that I've referred to as an electric field. So this basically is going to be an illustrative way in which we can be able to represent this aspect of an electric field. And a mathematical representation that I've said, of course, is going to be given as K, E, and then we're going to have this ratio of charge and the square of the distance between them given using that, of course, unity vector that I've given as R. So catch us in our next videos. We're going to look at different properties and characteristics of electric field, and perhaps some of the examples that we're going to use are going to assist us to quantify various aspects of this particular electric field. So that is it for now, guys. Bye. Catch us in our next video.